forgot to turn on the recording. Okay. Since I forgot to turn on the recording, I'll just briefly say what I have done. So this was so week 3 was, there was a problem. I just forgot to, sorry, I just forgot to. So there was a problem in week 3, this problem, and I have marked it. So there was a list as input and there was a while loop. So this first part will give you the largest value and remove the largest value. And the second part will find the smallest value and remove the smallest value from the list. And this whole thing, so for this whole while loop is under this. So this thing will continue till the length of the list is greater than 2. So that's what this is the input list 1, 4. And see, this is the input list. And for each of these for loops, like this for loop, for example, the largest value, which is 9, got removed after this. Then after this run, see the 1 got removed and like that. So then 8 got removed, this 3 got removed, because remove always, a list dot remove always removes the first element or the first occurrence of that element, not all the elements. So this 3 got removed, not this 3. Then again, this 8 got removed, then this 3 got removed, then 8 and 3, like that will go. So it's better I'll just, instead of this, I'll print this. To give a better understanding. Yeah. So first 1 and 9 got removed, then 3 and 8 got removed, then 3 and 7 got removed, then 4 and 6 got removed. So 5, 5, 4. So sum of 5 and 4 is 9. So 9 by 2 is 4.5. Okay. Yeah. So we'll start with today's problem solving session. And these are the questions. Okay. So from week 4, the first 2 are quite easy and straightforward. So just read the question. This is the first one. Okay. So write a program that takes number n as input and prints the sum of squares. Okay. Share. So okay. Of the squares of first n positive numbers. Okay. So if the number is n is 4, it should print the output like 1, 2, 3 square, 4 square. So is equal to 30. Should be. Okay. So very simple and straightforward, right? So what we'll use here? What are the things? So first thing will be, of course, n equal to, this is the regular one in terms of input. Provide a integer, or rather a positive integer, I'd say. So first one will be this one, will be the basic one, correct? So what are the others? So there, what we should run a for loop, right? So if we run a for loop here, we have to run the for loop. So first n positive integers they have told. So if it is 4, then it will be 1, 2, 3, 4. So the range, so for I in range, so what will be our range here? We'll start from the first positive integer is 1. So always start from 1, and since the loop, since the range goes till n minus 1, so we should write that n 1 to n plus 1. These things are now very clear to you by this time. So what will you get? So okay, I have to give I have to give something like some answer or something. So my first the answer is equals to 0. Okay. And when I'm initiating the answer is 0. And yeah, and then for I in this, so answer plus equal to, so answer equal to, this is squared. So I, sorry, the answer plus equal to, because I'm each, for each iteration, I am adding up the positive square numbers. So I square we write by I double star 2, and that's it. Then write answer. Okay. So let's see if we are getting the correct answer. Positive integer. So say 4, we're getting 30. Again, if I run 6, we're getting 91. We're giving 2, 5. Okay. 1 square plus 2 square is 5. Okay. So this was quite simple problem. This is done. And so let's move to the next problem. This is also a quite simple one. So write a program that takes a number n as input and prints the nth power of 2. Okay. So yeah. So for this one, so there could be two, though it's not very clear about this. So there is a number. So the number could be yeah, so here we don't need to take care. So it's any number it could be. You don't need to take care about any positive integer or anything. It could be any number. So 2 to the power 0.5 means root over of, sorry, root over of 2. So 2 to the power half basically. So if we take any number, it can take. So what we have to do again the same. So instead of positive integer, just provide a number. But doesn't need to be integer or anything. So this is, it's a straightforward, right? Answer is equal to 2 to the power n. Just 2-line code, right? It could be actually the 1-line code, because or rather we should not keep here int, we should give float here, because it could be any number, right? So if I just convert, so if I say if someone provides me 0.5, and if I do int of, say, just make it a string, int of 0.5, it should throw me an error. Please throw me an, because this point is not taken as a point, but taken as a English full stop. So instead of that, if I just put it instead of this, if I just put float, this will give me 0.5. And even some, so plus, and 2 to the power n is 2 to the power 0.5 will be true. So will be, so 2 basically to the power float of 0.5. So float means here any kind of decimal numbers are called in Python as float, because this is a computer science thing. So this is something like they say that this is in the memory, this point like floats. So it moves from document 1. So it moves from point 1 to point 2 to point 3 to point 4, just like that. So this like 1.4, 1.1, 14.1 if we move this floating point. Okay. Yeah. Sorry, no, okay, 1 second. I'll also tell that SN guest. So yeah. So after this, after telling this one, I'll tell you. So n float is equal to input and answer equal to per n. So if I again run this cell and guide gives say 8.2 or 8.5. Sorry, I have printed it. Print answer. If I run this cell, so some 362.03 it is given. Okay, and just if I keep it 2, give it 4. If I give it Q, it will give me 8, just like that. So every point takes. So someone has asked a question, sir. Every point takes slash. If the print statement takes slash in at the end by default, what do you do if you don't want that? So print has two. So print all is. So if you just go here and see that print has something as value, then there are two other options are also there. Step means separated. End is slash n. So but the by default the end is slash n. So now if I say okay, print 5, I just print 5 and with this just this in comma. If I say print 6, this will give me and sorry, this one is the semicolon. But now if I just give print 5 and make the clearly mention that no, make end equal to an empty string, not a space, but just an empty string. So this is the empty string. So inverted comma, either two single inverted comma or two double inverted commas are known as empty strings. If I give it empty strings, now it will present. See what it will print 5 and 6. But you have to mention that end is equal to a inverted comma, the empty string. Then only it will do. If I do end is equal to say and say something like this. See 5, this blah blah blah, and then 6. Okay. And there is something known as separator. So if I use instead of this end term, I use step is equal. Step by default is empty. So if I say give 8, for example, separated, it will not show me anything. But if I now give say, how do I explain? If I print multiple things, for example, if I print 5, 6, 6, see 5, 8, 8 will be not a good example. Say make it and use the step statement. So I'm not printing multiple things, right? I'm printing 5, 6, 6, and let's make this end is equal to star. Okay, what will I do? See 5 and 6 and 6 star 6. Okay, so I'm printing 5, 6, 6 different elements and then star. I hope this is clear. There are two extra arguments in print statement that you can use to not to make the default increment. So default for step is empty string and default for end is slash n, like new line. Okay. So okay, so we'll come to the difficult one for today's class. Print sum of a plus ab. Yeah. First of all, I don't know if your indentation, I'm just thinking your indentation is correct. Yeah. So that's what I was just checking. So this sum of AB won't work. So ABR, okay, yeah, you are doing this thing, but you are doing double thing. So you are doing a tuple, sum of a tuples basically. Yeah, this should work. So what is the problem here? Code is correct only. Print sum of A is equal to the entire number. Yeah, the code is correct. Though I can see the A and B are not on the same indent, and I hope that you are, and the C equal to A plus B are also not in the same indent. So your the return C is should be in the, yeah, print will take a slash n at the end, right? Because you are not. So if I am saying, yeah, print will definitely take slash n, right? So you have to give sum of this, comma, end is equal to this. That at that case only you will be not getting the not getting the slash n. Now it will not give the new line. Okay, you have to mention that end is equal to this inside the print statement. Okay, so we'll move to the next problem. Uh, why this write is? So write a program that takes a number n as input and prints a pyramid of number with n rows. Okay. So for example, if it is n equal to 5, it should print 1, 2, 3, 2, 3, 4, 5, 4, 3 like this. Okay. And not, so we'll first try. So n, we'll just now ignore the n equal to 10 and first try to see how we can solve this n equal to 5. Okay. So, so now whenever you are solving, um, so I'll see the SSC. I am not allowed to solve you the assignment. We have a programming assignment which I am not allowed to solve the programming assignment in this course, like in the current, for the current session here. So I cannot help you in this um, case. You can, yeah. So a program which you can edit the last two terms if we execute in the same is getting the pass for showing. So I'm not sure what it's this. I have to check first the assignment, and I'm not allowed to solve the assignment in the, like, this year's assignment in this class. Okay. So I'll see once and get back to you. Okay. So yeah. So 1, 2, 3, 2 like that pyramid is there. So how will you solve this kind of things? Now, whenever you are solving this kind of things, try to find the uh, repetitive structures which can be um, put inside a for loop. Okay. So what are the structure? What is the structure here? Now I just read. So this was the thing I need here. So I need 1, 2, 3, 2, 3, 4, 5, 4, 3. Now, if you just observe this pattern, you can clearly see that there is one pattern. First of all, is that first, yeah. So first the number of rows equal to n. So if you just go from say nx equal to 5, then first row is 1, second row will be 2, third row will be 3, fourth row will be 4, and last row will be 5. So first number of the each row is equal to I if I give a range from 1 to n plus 1, correct? So for I, if I say for I equal to 1 to 5 plus 1, that is 6, I'll get 1, 2, 3, 4, 5 for first row. Okay. Next thing we can also observe, there is a pattern in the number of spaces. What is the pattern here? So for each step of the pyramid, I am getting decreased by one space here. Correct. So there I have 4 spaces. Here I have 3 spaces. Here I have 2 spaces. Here I have 1 and here I have 0. What does this means again? So if you count the number of spaces, 4 plus 1 is equal to 5. 3 plus 2 is equal to 5. 2 plus 3 is equal to 5. Then 1 plus 4 and 0 plus 5. So what that is means, the number of spaces is actually is equal to n minus I. So 5 minus 1 is 4. So number of spaces is equal to 4. Then number of spaces is equal to 5 minus 2, that is 3. Okay. So so this is kind of one of the pattern. So let's first follow this thing and write the code at the first place. Okay. So yeah. So def, I'll say this as pyramid builder, the program name, end, and in this n, so first we have to write the number of spaces. How will you take that? For I in, so as I told, range 1 to n plus 1. N plus 1. So I'll just print the number of spaces. What are my number of spaces? I told you that print. Okay, print the number of spaces, that will be I into those number of space. That means I'll give us just empty string, and for just for identification understanding purpose, let's not make it space for the time being and make it say a dash into the n minus I number of spaces we have to print. So into n minus I. See if I'll just run it for 5 for the time being, and I'll say builder of 5. See if I now run this. See, I got spaces. Okay, let's just like here 43210. I also got it here. Okay, 43210. Correct. So first thing is done. Now let's see what are other patterns we can find. Now, if we again see the increase, so we have a part of increasing number and a part with decreasing number. So now again, if you see there is again another pattern that at the first row, the number of increasing number is 1. At the second row, the number of increasing number is 2. At the third row, the increasing number is 3. So like that. So at the nth row, the number of increasing number will be n. Okay. Now, if I initialize a value with I, because I have told you the first digit should always be the ith digit. That is if I'm making the range from 1 to n plus 1. So first row will be always the ith digit. So for I, if I initiate for this row, the number should be 1. If we initiate for this row, the number should be 2. If I initiate for this row, the number should be 3. So that means the number should initiate with I. So again, I'll initiate a number with another variable inside this. But so I'm printing line by line. Okay. And for one, yeah. And I have to mention here end is equal to none. Like means empty space, because I have to print like here only I have to print 1, right? Now I have to get the num. Okay, so num is equal to my I for this side. So for first row, the I is equal to 1, the second row I is equal to 2, the third row I is equal to 3, like that. So yeah. So next thing, what will you do? Will we do? So next thing, what we'll do that we'll iterate. Now again, see the increasing the number of the increasing numbers. Okay. So the for first row it is the number of increasing number is just 1. For second row 2 and 3 2. For third row 3 4 5. So 3. So now so that means if I iterate the number in range of I, okay, for that row, that is the first number of the row. So number of iteration is equal to the number equal to the first digit or the number of row, correct? Because you can see that for the for the fourth row, the number of iterations should be 4 because there are 4 increasing numbers. And after each iteration, I'll increase the num by 1. See if I do that, what I'll get? How do I write that first of all? So if I'm initiating the num with I for I in range of I, sorry, for k in range of I mean k or j, for j in range of I. So if I is equal to 2, I'll go from 0 1 2 times. Okay, 2 times here. So when remember, whenever you are giving the range from 0 to some number, you are basically iterating that many number of times. So if I'm giving just range is range I, that means the default start is 0. I am iterating the loop that number of times. Okay. So if I am giving it I number of times, so I'll say that okay, print I. Sorry, print not print I, print num, and increase the num after this iteration, increase the number by 1. If I'm doing the same, I'm doing this, increasing the number by 1. What I'll get now? Let's see. If I again run this loop, sorry. So again, I have to give end is equal to this one. Okay. And yeah, and at the end of the loop, of course, I have at the end of each loop. Yeah, at the end of each of this loop, I have to get a empty print statement to just print a slash n, correct? Because after this, so after this line, that means I am printing the first row. So after printing the first row, I have to give a empty print statement. Oh, sorry, it should be inside the for loop. Okay, correct. So it is inside the for loop. So now the increasing number is printed. Now, if you are, since you have understand, I can also remove this with a space and yeah. So for each of these loops, I am printing the first row. This is the first row. So after printing the first row at the end, I have to give a empty statement. So the first half of the pyramid is done. So as you can see, so this half of the pyramid is now completed. Okay. Let's see. And you can see that this is matches also. 5, 6, 7, 8, 9, 4, 5, 6, 7 similarly. Okay, the first half is done. Let's go for the second half. Okay, so now see the value of, first of all, at the end of this iteration, if I just give a breakpoint here and debug the cell and go till this one. See what is the num now at the end of this. So yeah, so now the num is this is the I is equal to 1. So I don't need to take care of this. Let's go for say when it printed the, yeah, I is equal to 3, 4, 5. So this question. What is the num now? Num is now 6 because after running the loop for the last time, I have incremented it to 6. Correct? This incrementation was done. Now that means, yeah, that means that after each iteration, after the each this row printing that now the first part is done. That increasing number is done. So what is the now decreasing numbers? Now see that whenever I'm ending the increasing loop, the num, though it is printing 3, but after printing is getting incremented because of num is equal to num plus 1. So the ending num is basically 5 plus 1. Correct? So that will be 6. But in this case, that's why it was 6. As you can see here, this was 6. So this is 6. Okay. Since I have increased it to 6 and then I have to start again with 4. Correct? So what I have to do? 6 minus 2. That will be 4. In this case, I have increased it to 8. 7 plus 1, 8. So I have to decrease it to 6. So that will be 2. So what I have to decrease it, basically num is now will be num minus 2. Okay. And if num is equal to now num minus 2, now how many times this loop should go? As you can also see here, if it's 2, then it's going for 1 time. If it is 3, it's going for 2 times. If it is 4, it's going for 3 times. That means I minus 1 time. I minus 1 time. So after the last iteration, the blue number is blue number plus 1. Okay. So for printing the decreasing number, so for example, at row 3, it will be 6 at the end of the loop. So for the first number of the decreasing series, the num should be num minus 2. So 6 minus 2 is equal to 4. 8 minus 2 is equal to 6. And the loop should run for I minus 1 times. So let's now again make another statement that, okay, sorry, it should not go here, but it should go here, that for j in, and don't make it okay, in range of, I have to make from till I'll to run the loop, the row number minus 1 time, so I minus 1 time. This is the row number. Let's don't make it I. Let's replace the I with for row. Okay, let's make it for row so that it will be easy to understand. Okay. For k in row minus 1 time, if I run the in row minus 1 times I iterate the loops, what I will print? I'll print again. Oh, sorry, I have to decrease after this thing. I have to decrease the nums also, right? If I decrease the num, I'll give num is equal to num minus 2. Okay. Again, I'm decreasing by 2. First, I'm decreasing the 2. Then I'm printing num and end will be equal to again empty string. Let's see if we can now. So this is our code. The code is done. At least for till 5, the code is done. Okay. So first I am here. I'll just comment so that you will actually understand. Print the leading spaces. Initiate num with row number and the print the increasing numbers. Okay. Then decreasing num to the first element of the decreasing numbers. Decreasing nums. And lastly, printing the TECR, decreasing numbers. Now, if I run this, some problem. 1 second. And sorry, here is the problem. Row to row. Okay. Should have given me an error, but it's not giving because there are still some variable in as I. Okay. All the eyes are now removed here. Yeah. Okay. It's giving me the pyramid. So I'm getting whatever is required. So 1, 2, 3, 2, 3, 4, 5, 4, 4. Okay. Why this is happening? Since this is a decreasing series, I was increasing the numbers. So I have to again decrease the numbers. Okay. Giving 1, 2, 3, 2, 3, 4, 5, 4, 3, 4, 5, 6, 7, 6, 5, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5. Okay. But if I now print till 5, this is done. Okay. Till 5, it is okay. But if I play 6, you will see there will be a problem. But there will be a problem. So what will be the problem? Now the number of digits has after 9, the number of digits becoming 2. But here we should not get 2. You have to give 1 digit. So which should be that 1 digit? Again, if you see that example here, the patterns example, it will get clear to you. Okay. See, so whenever there is a 2-digit number, for example, 6, 7, 8, 9, 10, 11, what is I'm printing here? 0 and 1. 7, 8, 9, 10, 11, 12, 13, 0, 1, 2, 3. 8, 9, 10, 11, 12, 13, 14, 15. So what I'm printing? The unit digit of that number. So if it would have been 102, I should have printed 2. Okay. But for the first digit, it should be two number. So for example, 10. Then if it is 10, then 10, 11, instead of 11, I'm printing the unit digit, that is 1, then 12 unit digits 2, 3, 4, 5, like that. So for 2 or 4 digits number, sorry, the spelling mistake, we need to use the unit place of that number except in the first number of the row. That is, for example, for 10, I'll use 0, and for 1001, I'll see 1. So how to find the number in the unit place? What is the logic behind that? How should we find that? The unit place? how to find the unit place number? Chat. Yes, correct. Number divisible by number. I'll divide the number by 10 and find the remainder of the number. So the remainder after the division with 10, that the syntax will be percentage 10 is the number in the unit place. That for example, in this case, is 14. So 14 slash 10 is equal to 4. So so everywhere I have to give basically, I have to give this one. For one digit numbers, it doesn't matter, right? Because for one digit numbers, anything one digit number by 10, it will give you always the remainder, that number. By 10. Everywhere basically I have to write else here. Okay. Should. Okay. And now if I do the same, after 6, perfect pyramid. If I do it for 16, I don't know if it will, again, a perfect pyramid. So you can always see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. After that 16, so 17 is 7, 8, 18, 19, 20, 21, 22, like that. And then here it is. Then what will be the my decreasing series will start, I think, from 19, 20, sorry, 17, 20, 21, 26, 27, 28, 29, 30, 31, then again 30, 29, 28, 27, like that is decreasing. Okay. So yeah, so that was the thing. So the idea is to, whenever you are trying to solve this kind of problem, always try to find uh, the repetitive structures, whatever structure you are seeing, right? This is showing. So so what we had done, so we first divided what are the structures. The first number of rows was n. Okay. Then we see that first number of each row is basically the row number, that is equal to the I. Then whatever the spaces, there was also n minus I. Then we see that increasing number. So for increasing number, we see that each time the first digit is basically the row number. Second, we saw that whenever the number of increasing numbers is basically how many times basically the number of increasing number is basically equal to the row, again the row number. So the what will you have, the iteration should be equal to again the I. And then we increased it, we increased it. Then we saw that at the decreasing row, it is basically just I minus 1. There is the row number minus 1, and we decrease it that much number of times. Then finally, what we saw for 2-digit things, we have to just divide it by 10, and whatever the number is there, that we have to just put. So that's why. So always try to find the repeated in this kind of problems whenever you get it in the exam or anywhere. Try to find the repetitive structures or recursive structures. Okay. Okay. And okay, this is done then. Let's go for the another problem. So this is a from the quiz is MCQ. So L1 there are a few movie names. L2 there are a few movie names. Okay. I'm initiating a empty list. What I'm doing here, I'm making a flag here. That's a variable called flag, and I'm iterating the list L1, not the L first to L. So I enter the list L1 and iterate the flag is equal to 0. What I'm seeing here, so for each element of this iteration, I am again iterating through the list 2. I am saying, okay, if the L1th ith element, that if, for example, if I'm going to the first element, if Harry Potter is equal to any of the element here, make the flag is equal to 1 and break this for loop and increase the flag is equal to and yeah, and then again run this and run to the next, go to the next element. Okay. So if I get flag is equal to 1, I'll go to again the second element. I'll not iterate to any more elements on this second loop. Okay. Else, if I don't find any matches, the flag is equal to 0. And if flag is equal to 0, I'll append that element, the I element, to my L list. What is basically it's seeing here? If there is any match with this element, any match of the any element of L1 with L2, I am breaking the loop. But if there is no match, I am keeping the flag 0 and moving the L1 to I. Listen, guess common elements. Common elements? Are you sure it's common elements? Just have a look. So whenever finding a common element, I am making flag is equal to 1. I am breaking it, breaking the loop. And if the loop is broken, the flag will be 0. The flag will be 1. So there will be no appendment, no append there. Okay. There will be no append here. So L1's option C. Are you sure? Are you sure option C? Okay. So what are the okay? Anyone else? Think that we are iterating only through the L1 for flag is equal to 0, but I'm not but I'm not iterating separately to the L2. I'm only iterating here till L1. If I'm getting a match with L2, I'm discarding that. And if I am not getting a match, then only I'm appending. SN guessed option A. Why option? Okay, option A. Let's see. So if I'm getting Harry Potter, so there is no mix here. So the flag will be always 0 and there will be no break. So it will the L will then L it will append to the to L. If it is matrix, I'm getting a hit here. So it should not get appended. Spider-Man, again I'm getting a hit. So it should not get appended. Avengers, I'm not getting any hit. John Wick, also I'm not getting any hit. So the L should have Harry Potter, Avengers, and John Wick. So what will be the answer? It will print the unique movies in the list. So option A is the correct answer. You just go Harry Potter, Avengers, and John Wick because I'm only iterating through the L1, but not to the L2. Okay. Clear for everyone? So this is our last question for the day. The number, a perfect number is a positive integer that is equal to the sum of its positive divisors excluding the number itself. For example, 6 is a perfect number because as a sum of its divisors is equal to 1, 2, 3. So it's equal to 6. You have to write a code for this one. So write a function which is return true if the function is a perfect number. So def perfect number will be an some n. So what will be the first thing? You have to first find all the positive divisors. So for the divisors, which will exclude the number itself. And what will be the divisors? For example, if I get 4, the divisors should always be less than 4. Correct? If I take 20, the divisors of 20 will always be less than 20. So it's basically a for loop. For I in the range of n, rather 1 to n, because anything divisible by 0 will be is undefined. So it will throw me an error, 0 division error. So it will be 1 to n. I don't need to go to n plus 1 because I am excluding the number itself. So I have to find out if I this sorry I something is divisible by some number means if sorry not n, the number n if divisible by I equals to 0 because the remainder will be 0. I have to make a answer with some divisors. So if I make some divisors and make a list, I'll say that okay, if n is equal to I equal to 0, then divisors dot append I. Okay. Finally, I have to see that if the sum of divisors is equal to numbers. So if sum of divisors equals to n, that is the number I'm providing to print true or gives me like return, rather I'll say return. Since you're giving me a return, so I should give a return true else return false. Okay. Okay. And yeah, this is the one of the way. Other way also you can do is if this is one of the way. Otherwise, instead, if you don't want to have a list, you can also do that. Uh, I'll come to that. So let's first work. Let's first do this. So now, so if I give 6, should print it. Should print it. So true. I am giving a 8. So what are the divisors? 3, 2. So what are the divisors for 8? 1, 2, 4. So it should not be a perfect number. False. For 9, 1, and 3. 6, 12 will be a perfect number. 1, 2, 4, 6. No. 12 will also not be a perfect number. False. Okay. And let's see from 1 to 20 how many perfect numbers are there. So for I range 1, 21, print I, others. Again, I will just make a separator is equal to this and this space. Let's see, anything is wrong. Oh, sorry. Indent here, so I'm giving a separator, printing the number, and if it's perfect or not. Let's print this. For sorry, print perfect numbers. I. Only 6 is true. We don't have any perfect number from 1 to 20. Let's go for 1 to 100. And let's see what are the perfect numbers. So if I'm just extending, if cost equals to true, then only print I and print I, comma, a perfect number. We have 6 and 28. There are two perfect numbers. For what are the divisors of 28? If I just see and run this 28, let's see what are the divisors. 1, 2, 4, 7, and 40. So 2, 1, 4, 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 14, 28. Okay. And 1 to 1000, how many we have? 628 and 496. Only 3. So it's going right. So there are only 4 perfect numbers from 1 to 10,000. 628, 496, and 8128. So like that, okay. Yeah, so this is not required actually. Just print. Okay, and so another thing we can do, instead of a list, we can also use something like this. Instead of this, you can also write, say, divisors. Say divisors will initiate the divisors with 0. And if it's an equal to y, instead of appending it, I'll just add it. So divisors is equal to plus equal to I. Okay. So I'm basically adding. So instead of sum of divisors, if I just say okay, um, I just comment this out and say if divisors is equals to n, then return me true. This will also work in the same way. Give me true. There's just a two-way where you can do. There is nothing. There is no. The both of the ways totally correct and perfect. Okay. If you think of some huge numbers, this will take some more space because I'm creating another list and summing them up time-wise and space-wise. But for the small kinds of things, it doesn't matter. And okay, so yeah, this were all the those and perfect. So we finished today a little rather before time. So any else, anything, anyone have any questions or anything, please can you tell me? If anyone have any questions, so I'll go through some of the week 4's quiz. So all the assignments I have solved to you. This is the quiz week 4, and there are quite easy ones. Which of the following statements are true regarding the magic square? The sum of each row should be m. Correct. Sum of each diagonal should be m. Sum of each column should be n. So all of these are correct answers. Correct, because in a magic square we always have the square numbers. Sorry, we always have like equal part. Which of the following statements hold true about n the magic square, where n denotes the number of rows and columns in the square? N should be even, n should be odd, n can be even or odd, n can take any value. So magic squares only applies for any odd numbers, but not for any even numbers. So n should be odd. Correct. And what are the following statements are true regarding the magic squares? A magic square is always a square matrix. True. A magic square can or cannot be a square matrix. False. The sum of each row and column is n into n plus 1 by 2. False. Sum of each row and column is n into n square plus 1 by 2. So the fourth one is also correct. So the correct answer is square matrix and sum of each row is 10. Hello. Uh, what is the output of the following code? So it is basically a doc string. So nothing will come. Said I've shown you the doc strings, correct? So for example, this is a doc string here. If I just run this, you should see there is no output. Nothing is there. Okay. So there is a sentence, no output. So correct answer will be no output. Which of the following operators should be exponent to a number? is the exponent to a number 2 to the so 2. So I've just today in this class only show you the any power means here the double stars. So there is a movie with 3 letters. How many combinations of names are possible? So basically, for each one combination, there will be 26 into 26 into 26 combination for each place. So it should be 26 to the power 3. So that will be 26 3 will be 17576. So it should be the correct answer. Okay. So this is from the last run. Yeah, this is from the last run. We are not allowed to solve questions from this year's assignment. Okay. One second. Yeah. Question 6. Yeah, 26 into 26 and 26. Because so if you just consider uh, 3 places. So example this, this, and this. So there are 26 letters, right? For each letter. So if I put A here, for example, I can put any of the 26 letter. For each letter, I can put 26 letter here, 26 letters here. Okay. So and so that means yeah, 26 possibilities for each letter. So this place also have 26 possibilities. So for each one possibility at for any one place, it will have 26 others, 26 others. So 26 into 26 into 26 is 26 to the power 3. Okay. So 26 to the power 3. If we go for 5, it's a go for a 4-letter movie. It should be 26 to the power 4. Just like that. Yeah. So for value of A, B, C, D is what is the value of A, B, C, D respectively? Now it's a 3 square. So it's a 3-box square matrix. So all the values will be 15, right? N square plus n into n square plus 1. So that by 2, what? 2, right? Because 2. So and this will be 1. This will be, if this is 1, so 8 plus 16. So for 15 minus 6, so this will be 1. 6 plus 2, 8. So this will be 7. So 1, 7. So 7 plus 5, 12. So this will be 3. So 1, 7, 3. And this will be 4, 2, 6. So 9. So 1, 7, 3, 9 will be the correct answer. 1, 7, 3, 9. 1, 7, 3, 9. Okay. This I have solved today. What would the output of the following code? For I in range of 5 to 20 is if I is divisible by 5. So that this means I remainder if I is divided by 5, if the remainder is equal to 0, that means I is divisible by 5. Print I squares. So print all the perfect square roots between 5 to 20. Perfect and not divisible by 5, not divisible by 5, 5 to 9, between 5 to 19, not divisible by 5, and perfect square roots between 5 to 19 and divisible by 5. Tell me, what should be the correct answer? ABCD. So, so if the range is from, so it's clearly printing all the square root that is divisible by 5. All the square that is divisible, the roots are divisible by 5. Basically, roots are, but are the roots between 5 to 20 or 5 to 90? This is a range. D, correct. Yeah, D answer. So what's the perfect square root? Squares with square root between 5 to 90 and divisible by 5. Okay. And this is the one I have solved you. This is one like on MCQ. I have solved it and shown to you. Okay. So yeah. So that's it for the day. So we'll stop here. And so if you have any questions, please let me know in the chat or in that forum, or you can mail me always. We'll end it here, and thank you all for joining. So there is no questions, right? Explain the seventh question once more. Which one was the seventh question? Let me see. Okay, that was simply a square answer. So I'll just reshare the screen. Okay, so since this is a perfect square, right? This is a magic square. Basically, it's a magic. This question is, since it's a question related to the magic square class, so this is a magic square. So magic square for sum of all the columns as well as all the rows will be 15. Also the diagonals will also be 15. So 6 plus 4, 10 plus 5, 15, right? So if I do 8 plus 6, if we have to get the sum is 16, so this should be 1. If I want to sum of this to be 16, this should be 6 plus 2, 8. So this should be 7. Then only we'll get to 15. If this is 7, this is 5, then I should get 3 here. So 8 plus 4, 12, 3 here. Similarly, 4 plus 2, 6. So 6 plus 9, 15. So 9 will be this one. So that's why 1, 7, 3, and 9. Okay. Okay. So we'll stop here. Thank you everyone for joining. Good night.